Yes, welcome back to the session. In this video, I'm going to discuss about torque acting on a dipole in a uniform electric field. Okay, so look at this diagram here. So we have a uniform electric field lines. So these are the uniform electric field lines. Okay, now what I'm going to do here. So I'm going to take a dipole. So dipole means we know that we have two charges. One is negative charge and the other one is positive charge, right? So according to dipole, so it is defined as when two equal and opposite charges which are placed at a certain distance. So here the distance of separation I'm taking 2L. Okay, so this is the dipole. Now I'm placing this dipole in a uniform electric field. Okay, so whenever a dipole is placed in a uniform electric field, it experiences two different forces. So along the positive charge, one force is acting. So F is equal to Q into E. Now in negative charge direction also, one more force is acting, that is opposite to the direction of electric field. So that is also equal to Q into E. So look at here, at a time we have two forces. These two forces equal in magnitude but acting in opposite direction. That means one force is acting positive x-axis direction, another force is acting negative x-axis direction, right? So as a result, these two equal and opposite forces, the net force becomes 0. So I'm going to write here, due to equal and opposite forces, net force acting on the dipole is equal to 0. Okay, so this is the force. Now we are going to calculate how much torque which is developed when it is placed in a uniform electric field. Am I right? So to calculate torque, we have a particular distance, correct or not? The distance is always perpendicular to the dipole, right? So I'm going to take a perpendicular distance. Just a second. Yes, so I'm going to take a perpendicular distance. Let us assume that is x. Okay, now this dipole, it makes an angle theta with respect to electric field. Okay, as we know that in rotational mechanics, torque acting on the dipole is, we can write it as torque tau is equal to F cross R, correct or not? Where R is equal to perpendicular distance, right? But instead of R, we are having x. So therefore we can write it as tau is equal to F cross x. Okay. Now we are going to calculate this perpendicular distance is how much. So look at this diagram carefully. We have a negative charge, positive charge, and this point, let us assume O. So it looks like a triangular shape, right? We know that if we apply sine theta, so sine theta is equal to opposite side by hypotenuse, right? So here opposite means x will be there, x by hypotenuse means 2l. So sine theta is equal to x by 2l. From this, x is equal to 2l sine theta, right? So this x value I'm going to substitute here. Then torque tau is equal to F into 2L sine theta. Okay, what is the force formula here? So look at this diagram carefully. Force is equal to charge into electric field, right? So I'm going to substitute that formula here. Therefore, tau is equal to QE into 2L sine theta. Okay, so we know that the definition of electric dipole, which is denoted by P is equal to charge into separation distance. So whenever charge and separation distance will be there, we can say that that is a dipole, right? So here also in this equation, we have a distance of separation 2L and a charge also present. So Q into 2L means we can write it as P. So therefore, tau is equal to PE sine theta. So this is the final expression for torque. Okay, suppose, say for example, if you want a vector form for a torque. So we can write it as in vector form. One second. So in vector form, the above equation we can write it as tau bar is equal to P bar cross E bar. So this is the vector form for a torque. Okay, so from this we have three different cases. That different case is also important sometimes for multiple choice questions for CBSE board level as well as a PU board also. Okay, so we'll discuss that special cases also. So coming to the small headline, special case. Yes. So coming to the special case number 1. If theta value is equal to 0 degree. So what is the meaning? So theta value is equal to 0 means both electric field as well as dipole both are parallel to each other. So I'm going to write dipole and electric field are parallel to each other. Parallel to each other. So we can say that theta is equal to 0, right? So this angle I'm going to substitute in this equation. So tau is equal to PE sine 0. We know that sine 0 value is 0. So therefore torque acting in an electric field also equal to 0. Okay. Suppose if theta is equal to 90 degree, then what is the meaning? Dipole and electric field both are perpendicular to each other, correct or not? So dipole and electric field are perpendicular to each other. So I'm going to substitute this angle 90 degree in this equation again. Then let's see what will happen. So tau is equal to PE sine 90 degree. Sine 90 value is 1, right? So therefore tau is equal to PE. That means this is the maximum torque. Okay, when a dipole is exactly perpendicular to the electric field, torque is maximum torque. So this will be the maximum torque. Okay, so this topic is most important for CBSE board as well as PU board as well as AP state also. Okay, I hope you understand. Thank you so much.